Here's another example of using the first derivative to figure out what's going on with a function. We've got this function f of x equals cosine x plus x over 2. Now, the x over 2 would just be a line that's kind of slanted up, and the cosine would just kind of squiggle along here. So put them together, we're going to get kind of a little staircase effect here on the function. Let's see what we can tell about it from the first derivative. So we look at the first derivative, and the derivative of the cosine is the negative sign, and the derivative of x over 2 is just 1/2. This is the way you have critical points is if the derivative is either 0 or undefined, and this is always defined, so the only way we'd have a critical point would be if that was equal to 0. And our critical points are going to occur when, let's see, if this is equal to 0, then that would mean sine x is equal to 1/2. Now we've got kind of a restricted range on this function. The angle is only allowed to go between minus 3 pi halves and pi. Let's think about on the unit circle, for what angles will the sine turn out to be 1/2 if the angle has to be in this range? We'll start with an angle of 0 and start turning until we get to pi. So starting at 0 and going forward to pi. See, the first time that happens is at pi 6, and that happens again over here. The sine is 1/2 again at 5 pi 6. So there's two critical points there. Now, as we start at 0 and go backwards to minus 3 pi halves, all the way back here to minus pi, the sign is negative, so it doesn't have a chance to be 1/2. Then it'll be 1/2 again once we turn pi 6 beyond minus pi. So we've got one more critical point. This one would be at minus 7 pi 6. So we've got three critical points on this function. And let's see what we can find out. Let's see, the starting point is minus 3 pi halves, and just after that is this minus 7 pi 6. And we got minus pi and 0, and then we get up to pi 6, and then we get to 5 pi 6. It's our last critical point before we get to the end, which is at pi. So between minus 3 pi halves and pi, we have three critical points. So at each of those, the derivative is 0. And we could actually analyze this in each of these intervals, look at the derivative. If the angle is between minus 3 pi halves and minus 7 pi 6, so you're turning all the way over here, you see the sign is more than 1/2. Essentially on this derivative, we're taking 1/2 and subtracting the sign. So if the sign is more than 1/2, we're going to get a negative number. So in this region, the derivative is negative. The function's going down. But in this region, so if you only turn back less than minus 7 pi 6 up to pi 6, here the sign is actually less than 1/2. So if we have the derivative is 1/2 take away the sign, that's going to be positive. So in this region, from minus 7 pi 6 to pi 6, the derivative will be positive. Now again, between pi 6 and 5 pi 6, now the sign is going to be more than 1/2. If we have 1/2 take away the sign, then the derivative is going to turn out to be negative again. And between 5 pi 6 and pi, so the last little bit here, the sign is less than 1/2. So if we have 1/2 and we don't quite take away 1/2, we're going to be left with a positive amount for the derivative. So our function's going down, level at 7 pi 6, and then up, and then down, and then up again. So, okay, that gives us a better sense of this function. What we might want to do is to plug in these particular critical values just to get some sense here. Well, actually, in the endpoints too, just to get a little vision of this function. Minus 3 pi halves, if we plug that in the original function, the cosine's 0 there, and if you take, if x is minus 3 pi halves, you divide by 2, you have minus 3 pi fourths. So 3 times pi is about 9, so negative 9/4. So the function's down here below the x-axis at that point, and heading down, right? So it must be heading down to minus 7 pi 6, down to some lower value here. Let's see, now it's heading, between there and pi 6, it's heading up. The cosine of pi 6 is root 3 over 2, and half of pi 6, let's see, that would be pi 12ths. Pi is about 3, so we have, at pi 6, we have, we say cosine of pi 6 is root 3 over 2, and then we're adding pi 6 over 2, so we're adding pi 12ths. So let's see, root 3 over 2 is, let's see, what's this, about 1.7, so half of that would be about 0.8, and another 0.25, so this is just a little bit more than 1, so the function's a little bit more than 1 there, and so it's moving up until it gets there, and then it's moving down until it gets to 5 pi 6. Let's see, at 5 pi 6 the cosine is negative f of 5 pi 6. The cosine is negative root 3 over 2, and then we're adding 5 pi 6 over 2, so that would be 5 pi 6 over 12. So this is about, let's see, we decided this number is about negative 0.8, and this number, 5 times a little more than 3 is a little more than 30, so a little more than 30 divided by 12. Let's see, we must be a little bit lower than this value, but we're still positive, so going down a little bit, and then after that we're going up. By the time we get to pi, the cosine of pi is negative 1, pi over 2 is about 1.5. We've climbed back up to about 0.5 here. So, I'd multiply this one. This is 3 times 5 is 15 over 12, right? So 15 over 12. That would be 5 over 4. So, yeah, that would be about 0.4, less than half. So then we come up here. We're just a little bit under that. Okay, so now we can see from our derivative, right, this first critical point was, it was actually the absolute min for the function. It was our lowest point. We started there, and then from there we were falling down. From there, we climbed up above the x-axis and never came back down. So this has to be the absolute min. Here we know we have a relative max. I guess we should figure out what's the comparison here. Actually, this value I think is higher than that one. When we find f of pi, cosine of pi was negative 1 plus pi over 2. So pi is about 3, so this is about 1.5. Take away 1, we get it's about 0.57 there for f of pi, and f of pi 6 was root 3 over 2. That's about 0.8. So that's already, then you add pi 12, so that's already larger than 0.5. So we have an absolute max here. And then we have a relative min at 5 pi 6. And we figure that all out from the first derivative.